Hello everyone. I'm back with the second video of chapter Surface Areas and Volumes in continuation with the first video of this chapter. So let's solve the remaining questions. From a solid cylinder of height 8 cm and base diameter 12 cm, a conical cavity of same height and same base diameter is hollowed out. Find the total surface area of the remaining solid. So from the cylindrical object whose height is 8 centimeter and the base diameter is 12 centimeter, then the radius will be 6 centimeter. So from this cylindrical object, a conical cavity of the same height is being hollowed out. And the base diameter of the conical cavity will be 12 centimeter and the radius is 6 centimeter. So we need to find the surface area of the remaining solid. So before finding the surface area of the remaining solid, let's find what is the slant height of the cone. So we need to find the slant height of the cone. So you all know the formula that slant height is equal to root of radius square plus height square, where radius is 6 centimeter and height is 8 centimeter. So it is 6 square plus 8 square, that is root of 36 plus 64, which is root of 100 equal to 10 centimeter. So the slant height is here 10 centimeter. So to find the total surface area of the remaining solid, total surface area of the remaining solid. So if we observe the outer surface area of the cylinder, so we are able to feel and touch the curved surface area of the cylinder. So that is curved surface area of cylinder plus we are able to, since it is cylindric solid cylinder, so the bottom base is there, that is base area of cylinder plus when a conical cavity is hollowed out, we are able to feel the curved surface area of the cone. So we will add the curved surface area of the cone. Curved surface area of cone. Just be careful. Please don't include the top face of the cylinder because from here only the conical cavity is being hollowed out. So this portion we will not be able to touch. So the top face of the cylinder, that is area of circle, not to be included. Just put the values. Curved surface area of cylinder is 2 pi RH plus base area of cylinder, which is in circular form. So area of circle is pi r square plus curved surface area of cone is pi r L. From these all three terms, first, second and third term, we are able to find pi r as common. So please take this pi r common out. So inside the bracket, we are left with, from the first term, 2h. From the second term, 1 radius is left, plus from third term, L is left. That is slant height. So put the values. Here, the value of pi is 22 upon 7 and the radius is 6 centimeter. 2 into height is 8 centimeter plus radius is 6 plus slant height is 10 centimeter. Solve it. 20 upon 7 into 6. So 2 into 8 is 16 plus 10 plus 6 is 16. So we get 20 upon 7 into 6 into 32. So solve it. We get it here. 22 into 6 into 32 will be 4 upon 7. Divided, you get the surface area of the remaining solid as 603.43 centimeter square. Next question. In the figure, from a cuboidal solid metallic block of dimensions 15 into 10 into 5 centimeter, a cylindrical hole of diameter 7 centimeter is drilled out. Find the surface area of the remaining block. So to find the surface area of the remaining block, total surface area of the remaining block will be equal to the total surface area of cuboid minus, from this we are going to subtract this area which is being drilled out. So 2 times of area of circle plus this curved surface area of cylinder. This is the inner curved surface area of cylinder. This we will be able to touch. So this to be added. So curved surface area of cylinder. This is the inner curved surface area of cylinder. So to find the total surface area of the remaining block, it is equal to total surface area of cuboid minus 2 times of area of circle, because this circular portion is being drilled out, so that to be subtracted, and the curved surface area of the cylinder to be added, because this will be able to touch. So write the formula. Total surface area of cuboid is 2 into length into breadth plus breadth into height plus length into height minus 2 times of area of circle is pi r square plus curved surface area of cylinder is 2 pi r h. Now see the values here. Diameter of the cylindrical hole is 7 centimeter. So the diameter is 7 centimeter, then the radius will be equal to half of the diameter. And here length of the cuboid is 15, breadth is 10, and the height is 5 centimeter. So the height of this cylindrical hole will be 5 centimeter. So height of the cylindrical hole will be equal to the height of the cuboid. So let's place the value. So 2 into length is 15 and breadth is 10 plus breadth into height, which is 5, plus length is 15 and height is 5, minus 2 into the value of pi is 20 upon 7 into r square, where radius is 7 upon 2. So r square will be 7 upon 2 into 7 upon 2 plus 2 into the value of pi is 20 upon 7 into radius is 7 upon 2, and the height of the cylinder is equal to the height of the cuboid, that is 5. So solve it. 2 into, this is 15 into 10, that is 150, plus 5 into 10 is 50, plus 5 into 15 is 75, minus, cancel it. So we get 11 into 7, that is 77, plus, cancel this also. So 22 into 5 is 110. So it is equal to 2 into 150 plus 50 is 200. 200 plus 75 is 275, minus 77 plus 110. So 2 into 275 is 550, minus 77 plus 110. So 550 plus 110 is 660, minus 77, that is equal to 583 centimeter square. So this is the surface area of the remaining cuboidal block. So we need to find the volume of the remaining block. So to find the volume of the remaining block, here we are going to subtract the volume of cylinder from the volume of cuboid. This portion, the cylindrical portion, is being removed. So from the volume of the cuboid, we are going to subtract the volume of cylinder. So that will be the volume of the remaining block. So volume of the remaining block will be equal to volume of cuboid minus volume of cylinder. So volume of cuboid is length into breadth into height, minus volume of cylinder is pi r squared h. So here the dimensions, here it is given 15, 10 and 5, where the height of the cylinder, as I already said, will be equal to the height of the cuboid, and the radius is 7/2. So put the values here. So length is 15, breadth is 10 and the height is 5. Let's check the values, dimensions again. Yeah. Minus the value of pi is 22 upon 7 into the radius is 7 upon 2. R square will be 7 upon 2 into 7 upon 2, and the height of the cylinder is equal to the height of the cuboid, that is 5. Solve it. 15 into 5 is 75. 75 into 10 is 750, minus, cancel here. So it is 11 into 35, which is 385 upon 2. So which is equal to 750 minus 385 upon 2 will be equal to 192.5. So subtract 192.5 from 750, we get 557.5 centimeter cube. So this will be the volume of the remaining cuboidal block. So let's see what is there in the next question. 150 spherical marbles, each of diameter 1.4 centimeter, are dropped in a cylindrical vessel of diameter 7 centimeter containing some water, which are completely immersed in water. Find the rise in the level of water in the vessel. That means we need to find the rise. That means we need to find the height. So just see, a cylindrical container is there. So height of the cylinder is not given. Rather, the diameter of the cylindrical vessel is given, that is equal to 7 centimeter, and the radius will be equal to 7 upon 2. And this cylinder contains some level of water here. So in this cylindrical vessel, 150 spherical marbles are dropped, whose radius, whose diameter is given here as 1.4 centimeter. Diameter is 1.4 centimeter. Then the radius will be equal to 0.7 centimeter, that is equal to 7 upon 10 centimeter. So here we need to find, and you all know that when an object is dropped in a cylindrical vessel which is filled with partially filled with water, then the level of the water will increase. If we drop some object in the container which is filled with water, then the level of water will increase, and we need to find this rise in water. Volume of this water will be equal to the volume of the marbles placed inside the vessel. So here, volume of the rise in water will be equal to the volume of 150 marbles. So since this is the cylindrical portion, so the volume of cylindrical portion will be pi r square h, that will be equal to the volume of 150 marble, that is 150 into, and each marble is of spherical shape, so the volume of the sphere is 4 upon 3 pi r cube. So here I am just replacing the value of radius of cylinder as capital R, because radius of cylinder and the radius of marble both are different. So I am using the radius of cylinder as capital R. So now put the values, cancel this pi and this pi. So R square is 7 by 2 into 7 by 2 into, we need to find this height, that is rise in the water level, equal to 150 into 4 upon 3 into, here r cube. In place of r cube, we are going to write 7 upon 10, because the radius of the spherical marble is 0.7, that is 7 upon 10 into 7 upon 10 into 7 upon 10. So we can cancel this 7 and this 7, this 7 and this 7, this 0 and this 0. Cancel this 15 with this 3. Now write the values here. H will be equal to 5 into 4 into 7. So it is 20 into 7 into 4 upon 100. So cancel this 0. So here we are left with 14 into 4, which is 56, divided by 10, that is equal to 5.6 centimeter. So the rise in the water level is equal to 5.6 centimeter. Next question. A sphere of diameter 12 centimeter is dropped in a right circular cylindrical vessel partly filled with water. If the sphere is completely submerged in water, the water level in the cylindrical vessel rises by 32.9 centimeter. Since the water level rises by 32 upon 9 centimeter, so this will be the rise in the water level, that is H. Find the diameter of the cylindrical vessel. See, if you compare this question with the previous question, in the previous question, diameter was given and we were supposed to find the rise in the water level. So just it is reverse. Here the rise in the water level is given and we need to find the diameter of the cylinder. So this way of solving is just same as we solved in the previous question. So in a cylindrical vessel which is partly filled with water, and here a sphere is placed inside the vessel and the diameter is given here as 12 centimeter. Then the radius will be equal to 6 centimeter. So when a spherical ball is placed, so a water level rises and the rise in the water level is given here as 32 upon 9 centimeter. So it's very clear the volume of the ball which is placed inside the vessel will be equal to the volume of the water level. So let's write the formula here. Volume of the rise in the water level will be equal to volume of sphere. So volume of rise in the water level, since this is cylindrical in shape, so the volume of the water will be equal to pi. I'm using capital R for the radius of the cylinder, pi r square H equal to volume of sphere is 4 upon 3 pi r cube. So cancel this pi, and here we need to find the diameter of the cylindrical vessel. So we don't know the radius, so it is r square, and height is given here as 32 upon 9 centimeter. So it is 32 upon 9 equal to 4 upon 3 into radius of the sphere is 6 centimeter. So r cube is 6 into 6 into 6. So solve it. Cancel it first. Cancel 32 with this 4. Cancel this also. Wait. So here r square is equal to, shift this 9 the other side. So 3 into 3 is 9 and shift this 9. So it becomes 9 into 9. So radius is equal to 9 centimeter, and we all know that we need to find the diameter of the cylinder, and diameter is 2 times of radius, that is equal to 2 into 9, which is 18 centimeter. So this is the diameter of the cylindrical vessel. Next question. To sudden floods, some welfare associations jointly requested the government to get 100 tents fixed immediately and offered to contribute 50% of the cost. If the lower part of each tent is of the form of a cylinder of diameter 4.2 meter and height 4 meter, with the conical upper part of the same diameter but of height 2.8 meter, and the canvas to be used cost rupees 100 per square meter. Find the amount the associations will have to pay. So here just a tent, 100 tents are to be made. So just let's draw the figure for the tent. The lower part of the tent is cylindrical part. And the upper part of the tent is conical. So here the diameter of the cylindrical part is given here as 4.2 meter, where the radius will be equal to 2.1 meter. And the height of the cylindrical part is given here as 4 meter. And the radius of the conical part of the tent will be same as the radius of the cylindrical part of the tent, that is 2.1 meter. Height of the conical part of the tent is equal to 2.8 meter. So we need to find the cost of the canvas being used. So to find the cost of the canvas being used, first we'll find the total surface area of the tent. So since we know to find the total surface area of the tent, it will be equal to third surface area of the tent, that is conical part of the tent, that is pi r L, and the curved surface area of the cylindrical part of the tent, that is 2 pi r h. So to find the total surface area of the tent, we need to find the slant height of the conical part of the tent. So slant height is equal to root of r square plus h square, where the radius is given here as 2.1 meter whole square plus height is given here as 2.8 meter whole square. So write 2.1 as 21 upon 10 whole square plus 2.8 as 28 upon 10 whole square for easy calculation. So 21 square is 441 and 10 square is 100 plus 28 square is 784 upon 10 square is 100. Solve it. So we get 1225 upon 100. So find the square root of 1225. So we get 35 and the square root of 100 is 10, which is equal to 3.5 meter. So the slant height of the conical part of the tent is 3.5 meter. So we need to find the total surface area of the tent. Total surface area of the tent is equal to third surface area of cylinder plus third surface area of cone. So curved surface area of cylinder is 2 pi r h and curved surface area of cone is pi r L. So here we observe that from both the terms pi r is common. So let's take pi r common out. So we are left with 2 into h in first term and the second term we are left with L. Now put the values. The value of pi is 20 upon 7 and radius here, radius of tent is 2.1 meter. And 2 into the height of the cylinder is 4 meter. So replace h as 4 plus slant height just we calculated, that is 3.5 meter. Solve it further. Cancel this 7 with 2.1. We get it as 0.3. So 22 into 0.3, we can write it as 3 upon 10, and 2 into 4 is 8 plus 3.5. So it is 66 upon 10 into 8 plus 3.5 is 11.5. So multiply 66 with 11.5, we get 759 upon 10, that is equal to 75.9 meter square. So now we need to find, this is the surface area of one tent, and here in the question it is given 100 tents are being fixed. So we need to find the surface area of 100 tents. So surface area of 100 tents will be equal to surface area of one tent multiplied by 100, which is equal to 7590 meter square. So we found the surface area of 100 tents. So now we need to find the cost of canvas. Cost of canvas used to make 100 tents. So here the cost is given as 100 per square meter. So the cost of canvas used to make 100 tents will be equal to 7590 into 100 per square meter. So we get 759,000 rupees. So we need to find how much amount is paid by the association to the government. So it is given here 50% of the cost is being paid by the associations. So let's find the cost paid by the associations. So the amount the associations will pay will be equal to 50% of the cost of canvas used to make 100 tents, that is 75,900. So cancel this. Multiply 5 with 75,900. We get the value as 379500 rupees. So this much amount the associations will pay to the government. So now is the time to check your understanding. Solve these 3 questions and write your answers in the comment box. Do subscribe this channel to get updated with the forthcoming videos, and share this video with your friends.